Hello and welcome. In this video, we're just going to quickly look at the process of configuring network interfaces using files off the command line. So yes, as it says in the introduction, managing network interfaces using a file. Just a quick note, the file format that I'm going to discuss here ends with CentOS 8. For newer releases after that, it switches over to, it's called a key file, which is formatted differently. I will eventually do a video on that, but right now I'm focusing on the older style because, well, many of my students are still going to be encountering machines that use the older format. So yes, we're going to look at the older format, and this is going to allow you to control how your machines connect to the network. So to make permanent changes, we're going to go to a directory /etc/sysconfig/network_scripts and look for a file typically called ifcfg- the name of the interface. Again, with the newest releases, actually CentOS 8 and up, you can actually see this called something else, but the older standard was ifcfg- the name of the interface. So something like ETH0 or ENS33 or ENP1S0 as the virtual machines I use for demonstrations happen to have. If you're not sure what the name of the interface on your machine is, you can always look it up using the command iplink show. Now we're going to go to that file, and inside it you're going to see a number of variables or parameters that control the behavior of that particular interface. There are actually quite a few parameters that you could put in this file. We're only going to scratch the surface on it. We're going to see the ones that you absolutely need. I probably won't end up doing videos on all of the different parameters that you could use for the older style. I probably will end up getting around to doing that for the newer style. So at the absolute minimum, there are 4 things we need in this file. Actually 3, because 2 of them sort of control the same behavior. HWADDR, the MAC address of this particular interface. This allows the machine to be absolutely certain that this file corresponds to one particular interface. Because that MAC address, barring somebody manually changing it, should be unique. As an alternative, you can use device and include the name the system gives the interface. This used to not be so reliable. You would run into problems where you would start a machine, you'd set up a file, and the interface would be called ETH0, but maybe somebody changes some hardware configuration of the machine, and the next time you boot, that interface is actually ETH1, and now there's a different interface that's ETH0. With the newer standards of naming interfaces that I'm not even going to go into in this video, it's where you'll see things like the ENP1S0, like my interface is called. This becomes more reliable because those names don't change. If you're unsure if it's going to change or not, stick with hardware address. You can be absolutely certain that it doesn't change. And honestly, put in both. It doesn't hurt anything to have both in there to make sure this file corresponds to this particular network interface. Beyond those 2, you absolutely need bootproto to indicate what is this interface going to be doing when the machine turns on. I was getting confused with onboot, which is the next one. If you set bootproto to DHCP, this interface will attempt to get a DHCP address. If you set bootproto to be either none or static, it will try to get a static address. If you read the documentation, the official value you're supposed to put in is none, but some people seem to find that confusing, where it looks like it doesn't have a protocol when it turns on. So many people like to use static, admittedly myself included. It creates a clearer file. And finally, on boot, does this interface turn on when the machine boots? Typically, this is going to be set to yes. That is, turn this interface on when the machine boots. Occasionally, though, there might be some situations where you have an interface that you don't want turned on automatically. The machine that I had in my old office had two Ethernet interfaces and a wireless interface. I would only ever be using one of those at a time. Initially, I had the wireless interface set on all the time because the office didn't actually have a physical network connection for me. But once they actually got around to putting in that network jack, well, then I really only needed, most of the time, that one Ethernet connection, and I could set the others to be off so they weren't, cluttering up my interfaces when I was trying to work on other things or trying to do something on my network. So we'll take a quick jump over to my demo machine, and this is one of the few times where I'm actually going to use sudo -i to more permanently gain elevated privileges, simply because, as I'm sure you've seen, if you try to use sudo to cd to a directory you don't normally have access to, the command runs, but then it immediately kicks you back to where you were. So I'm going to use -i instead, and for a few minutes, I effectively become root. And I'll head over to etc sysconfig network scripts. And I can't remember if that file was there from the default or if that was from me setting this up earlier, but let's take a look. That's from me setting this up earlier. So you can see I've included the hardware address, the unique MAC address of this interface, boot proto set to DHCP, so this interface, when it turns on, will attempt to get a DHCP address, and on boot equals yes. When this machine turns on, this interface will turn on. Just to be sure that that is in fact the right interface, enp1s0, we can always do our IP link show. This machine only has a loopback interface and that one Ethernet interface. If you've got more interfaces and you're not sure which one is the right one, you could always use IP address show to look at the address, or try a process of elimination and see which interface is which. And of course, in that output, we can see that MAC address that I included in that file. Now, I did mention in the slides not to confuse device with the parameter name. Name is used by us as admins to refer to this interface. Device is what the machine is going to use to always be sure this file is this interface. In theory, though I find it's not 100% reliable, what we should be able to do is go into that file, and if I put in, say, name equals, just trying to type wired, in later commands, I should be able to use wired to refer to this interface. Now that I've done that, though, there are some things that I need to do, per usual, to get the machine to understand and recognize that I have changed configuration. So yes, for a dynamic address, we set boot proto to DHCP, and when we do that, that will make this interface at least try to obtain its IP address, its network information, its gateway, any DNS servers that it has, and information about the named domain that it's in from a DHCP server. Assuming there is one, it works, If there's not, it's going to fail and then your interface doesn't get an address. In my case, I do have a DHCP server, so this will work. In fact, we saw that machine already has an address, so we know it worked. But we have just made a change. We've changed a configuration file, so we need to do something to force the machine, or tell the machine, we've made changes and it needs to use the new info. In older releases of Linux, you could use if down and if up to turn an interface off and on again. And of course, these would require elevated permissions, so I probably should have included sudo on that slide. I'm not even going to use those commands on this particular machine that I'm demonstrating with, because it's using CentOS 8 Stream, so those commands aren't even included by default anymore. If you are still using those, start getting used to the new commands. The more modern releases use the nmcli command to control interfaces. In this video, I'm not going to go into any kind of depth with that command. I will, at some point, create a series of videos on nmcli to control and manage your interfaces. You could use it to set up the addresses or to set up the DHCP like we just did, but that's for a different video. Right now, all we want to do is tell the machine, reread the configuration for this interface. So that's nmcli connection reload. And if you just type in that command with no other arguments, it's going to reload all of your connections, or you can specify a particular interface. So this should force it to reread that interface configuration file. So I'm actually going to get out of being root because I don't even need to be in that network scripts directory anymore. I should have done that earlier. And I will sudo nmcli connection, if I spell it right, reload enp1s0. Now the only thing I had actually changed there was the name of the interface, which we might be able to see with ip-link show. No. Well, it didn't complain about there not being an interface called wired, so I'm fairly certain that worked. And the reason we might set the name like that is just because the newer standard for naming interfaces, well, it's nice that it makes sure that name is unique and will never change. Sometimes it can come up with names that are somewhat difficult to remember. enp1s0 isn't so bad. The wireless interface in my old office was W1PS7F something. Not something I want to have to type in repeatedly. So it was easy enough to just go in the file, name it wireless, and then I could easily say, oh, that's my wireless interface. Now, if we want to set a static address, there's a bit more that we have to do to this file. First, we'll go to bootproto and change that to be static, or none. Either one will work. But once we've done that, now we need to provide that machine with its address and network information. So we will need to give it IPADDR for its IP version 4 address, prefix for the CIDR prefix, the CIDR notation, the number of bits in that address that represent the network. So you'll commonly see something like 16 or 24, or if you're subnetted on not one of the old class-sized networks, you might see a different value in there. It would be nice if prefix would be rolled up into IP address at some point, but that hasn't happened. You do need to define it separately. An issue my students commonly run into is when they're looking up documentation online, they might find some older documentation. For example, in this case, I often get students trying to use netmask or network or there was a third one. I can't remember, and it doesn't matter because those are all obsolete and should not be used. Use IP-ADDR and prefix. So those allow you to set up the machine's own IP address, and that tells it what the broadcast address should be. If this machine is supposed to be able to reach anywhere outside the local network, you do need to give it a default gateway. You might not do this for every single interface the machine has, but typically at least one of the interfaces will have this. So you can put in gateway equals the IP address of your default gateway. And generally, at least one, but possibly up to 3 DNS servers. DNS1, DNS2, and DNS3. So up to 3 DNS servers that this machine can use to perform hostname resolution. In the order listed there, DNS1, 2, and if that fails, it will fall back to DNS2. If that fails, it falls back to DNS3. Rather than typing this out live, I've actually grabbed a terminal already set up ready to go with a CentOS 8 machine that is configured to still use this standard. So I'm going to go sudo-i on there. Head over to etc sysconfig network scripts. There's my interface file. This machine also happened to have enp1s0. You'll notice its MAC address is different. So let's make sure it is going to get a static address. Let's do IP address show. Oh, I already gave it a static address. Right. Well, let's see how I did that. We'll just go in, VI or whatever editor you happen to prefer, that file, and we changed boot proto to be static again, or none. In this case, I put in device, not MAC address. I really should have hardware address in there. I'll actually just copy that in a moment just to make sure it's in there. On boot is yes, because I want this interface to turn on when the machine boots. IP-ADDR, the static address that I'm giving this machine that it is going to always have unless I manually change it, or another admin manually changes it. The prefix, the number of bits of that IP address that represent the network. So because I said the prefix is 24, this machine can figure out that this network is 192.168.122.0/24. The gateway, that is if I want to reach anything outside this local network, that's the IP address I send the traffic to achieve that. And one, or I'll add a second one in a second just so we can see that work, one or more DNS servers. Now, in order to put that MAC address in there, I'm just going to hop out here, copy it, took me a second because this keyboard lays out the insert key in a slightly odd position. And I'm going to set my DNS2 to be 1.1.1.1. Now, just like before, and I will exit root or exit that elevated privileges session because I no longer need it. Just like before, I've made some changes to my file. I need to do something to tell the machine I've done so and that it should recognize those changes and start using them. So I will again sudo and then CLI connection reload enp1s0. If I IP address show, nothing should have actually changed there because all I did was put in the MAC address and this machine already recognized that, and set up a second DNS server. So if I look in etc resolve.conf, it didn't actually recognize that yet. Sometimes that happens, it just decides it doesn't want to recognize the change immediately. We can restart Network Manager. There we go. Now it knows about the second DNS server. That forced it to reread everything. So what we've looked at in this video is just a quick examination of the files that we can use to configure network interfaces on the machines under our control. As I started off by saying, this isn't quite obsolete yet. There are still machines out there that are using this style of file, but it's not actually going to last all that much longer. The newer releases have switched over to a different format of file. Whichever format we're using, the whole idea behind this is now we can control communication with our machines. Now you'll notice one thing that I haven't done with this connection yet is actually test to make sure that it works. Something that I always go after my students for not doing. You make a change, you have to test to make sure that it works. This video is long enough already. I'm going to deal with it or set up a separate video to handle the actual testing process. I will see you there.